Hello everyone, today let's study together about advanced classification method by using support vector machines and a neural network with scikit-learn. So first we have to import pandas library as PD, and it's used for handle data manipulation. So first step 1, we have to create the dataset which has three features. They are age, salary, and purchase. For 0, it stands for didn't purchase or no, and 1 is represent as purchase or yes. And then we convert it into a pandas data frame for easily analyze. Data frame in here it means that it divides each features into a rows and column. So you can see it by see this output. So next df.shape, which means that it takes the totals of rows and columns of dataset, which has 12 rows and 3 columns. The second step is split data into training set and testing set. So in order to divide data into two parts, we have to import library from scikit-learn, which is scikit-learn.model selection, import train task split. So first we have x variable for input feature age and salary that used for predictions, and we have y variable for purchase that used for target variables. And after defining x and y, we have to split the dataset to x train y test, y train and y test for train test split, and we have a test size 0.25, which is we divide 25% for testing sites, and another 25% is for training sites, and random state equal 42. It used it to ensure consistent result across run. And then let's see the result of training set. This is the training set, and another one is for testing set. And when you see the output, you see that the index numbers are not in order because of use random state 42, that it makes shuffling randomly. So after splitting data into two parts, let's move to step 3, which is SVM classifier implementation. And for the library of SVM classifier implementation is scikit-learn.svm import svc. So first of all, we have to create the models. SVM classifier for SVC is get from the library. Kernel linear, it means uses linear decision boundary. C equal 1, it means that regularization parameter which control how strictly the model try to classify every training data point correctly. So if you use small c, example 0.01, it might be overfit or underfit, and if you use larger c like 100, it might overfit. And for training state equal 42, it means that it keeps running until 42 times. And for the next part, after recreating the model, we have to training the model by using fit method. So after we train the model on training data, the next we have to predict the result on test data, which for X test. Based on this outcome, for this part is for y test, the actual values, and this one is for predictions. So you can see that the actual values and the guessing values is the same. So it means that SVM classifier was guessing correctly. And next, we also can use confusion metric to see exactly how the model performs for each classes. And there is also another way of using confusion metric by using dot level, which means that it will show the metric only in one row. And then what is TN? which is true negative. The model predicts 0 and the actual value is also 0. FP for positive, which means the model predicts 1 but the actual was 0. For false negative, the model predicted 0 but the actual was 1. And lastly, true positive, it means the model predicts 1 and the actual value also 1. So what is 2, 0, 0 and 1 want to tell us? So 2 is, which means the model correctly predicts 2 samples as class 0. And 0, it means that the model never incorrectly predicted 1 when it was 0. 0, model never misses a 1, predicts 0 when it was 1. And for 1, a model correctly predicts 1 samples as class 1. So now let's see the accuracy score together. It shows us how accurate the SVM classifier is. 1, which is 100 because the model made no mistake. So now let's see the classification report. And don't forget to add its library. Here's the classification report. It tells us every details of classification. For predictions, it means that how many were correct. Means the SVM didn't miss classifying any negatives as positive. And for recall, it's no positive case was mistakenly missed. For F1 score, it's balance between precisions and recall. For support, it means the number of actual samples of each class in test data. For accuracy, it's 100%. Macro AVG, it means average, so the average of precision recalls F1 score across classes, treating all classes equally. And weighted average, it means average precision recalls F1 score by the number of instances in each data. So now let's move to step 4 by using neural network classifier. And for this one is the library of neural network. So first we have to create the model. So LP classifier is get from library. Hidden layer size equal 5. It means that it has one layer hidden in final. Activation equal ReLU. ReLU is from rectified linear unit that activate function for nonlinear relationship. And so Adam as well, it means it optimizer that update weight efficiently makes iter equal 1000. It means that the model can train up to 1000 times. And lastly, random state equal 42, which means make the result reproducible. After creating the model, we have to train the model to learn the relationship between feature X trend and Y trend by using fit method. Next, after training, it has to predict the result for each task. And as you can see in this output, for this side, it means for Y task, the actual value. And for here, it means the predicted value that get from Y predict and N1. You can see the difference in the middle one. For the value, the true value is 1 and prediction is 0. It means that the model made one mistake. And after that, we have to check the accuracy. Since the model made one mistake, the accuracy can get only 0.66, which means that the neural network was right only 66.36%. And then let's check together with classification report. As you can see, 0 divisions equals 0, which means it tells that if precision or recall can be calculated, just show 0 instead of showing error. Based on classification report, we can say that neural network didn't perform well since accuracy is only 67%, and for class 1, precision, recall, and advanced score are all zero. It means the model completely failed to predict bias. The reason that neural network didn't perform well due to small dataset, because we have only a few samples, 12 totals and 3 tasks. That's very tiny for neural network to work, because neural network usually need a lot of data to learn patterns properly. Even one wrong prediction, it can change accuracy a lot. Also, small dataset can cause model to perform poorly as well. So now let's move to step 5, which is the last step. It's about comparison of two classifiers. And then let's see the different output between SVM predictions and neural network prediction. And the SVM predictions, it's just the same as actual values, but for neural network predictions, it's not. It has one mistake here. So let's start from here for today about advanced classification method. We will see you again later. Goodbye.